Okay, so the problem for today is 1155 number of dice rolls with target sum. So this problem, I tried it previous time and I did manage to solve it like within like 30 minutes. Now I know the solution approach, I'll try to do that. So this is seems like DP problem. We have n dice as draws and the dice is like have k faces from 1 to k, and I need to return the all combinations of dice draws, number of combination of dice draws that add up to the target. So the problem is the following. So
Oh, it's raining. I see that it's raining.
let's
Rain, welcome back.
let's assume I have
Rain, 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 rainy, rainy, rain.
so we have here
I am in the bedroom. I am in the kitchen.
we have, let's say,
Yeah, I do not like the meal equals.
n equals 1, or like draw. First draw, on the first draw, and let's assume we have this array, and let's say we have k faces equal 3. On the first draw the target, I will save the target in this array. So the target is
Ew, this looks gross.
0, then target 1, then target 2, and under index 3 gonna be a target 3, and the index 4 gonna be target 4, then 5, 6, 7, 8, 9, 10, 11, and 12. Assume that. And say we have n equals 3, like 3 draws. So on the first draw, first, the target 0 is 0, and the target 1, 1, target 2, 2, 1, and target 3, 1. And all remaining is zeros, because we cannot get more than 3 in the first draw with the dice that have 3 faces. So first one was this. So here 0, 0, 0, 0, 0, 0, 0. On the second draw, what gonna be the formula for the second draw? The second draw, let's say it's dp draw equals 2, or like just 2, and here gonna have target, and the dp gonna be the number of combinations that equals target on the second draw, and it's gonna be uh, so target dp of the target minus 1 on the first draw plus dp number of combinations that adds up to target minus 2 on the first draw plus number of combinations that add up to the target minus 3 on the first draw. So let's assume we have and if the minus, let's say um, j is um, is greater than, is less than, let's say this is a uh, m draw. If it's t minus j gonna be less than on the like m's row gonna be less than m, then its dp should be equal 0 of the on the m's row t minus j. And if the on the m's row t minus j greater than m by k, then then dp on the m's row t minus j equals 0. So this condition is for the minimal value. So you cannot get less than m on the m draw total score. So it means that if you gonna get 1 1 1, so you cannot get 0 for the draw. So for if you have like m draws, like let's say you have like score 1 plus 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 score m. So this sum, because every element is greater or equal 1, greater or equal 1, so this the total sum should be greater or equal m. And also because every element is less than or equal k, this one also less than equal k, the total sum should be less than or equal m by k. If this condition doesn't hold, I'll just nullify it like as if it doesn't exist. So for this one, let's say for the 0, um, nothing, like second row. For the first score, for the target dp or target 1 on the second draw equals dp of t minus 0 on the first plus dp minus 1 on the first plus dp minus 2 on the first. So this one is 0 and all of this is equal 0. So here is 0. And let's assume I want to calculate dp of the target 2 on the second row. It's equal dp of the target 2 minus 1 on the first row plus dp 2 minus 2 on the first row plus dp 2 minus 3 on the first row. So this one is equal 1, this is equal 0, this is equal 0. So 0, oh, 1 here, 1. And it's easy to see that we are targeting the remainder, the sum of the kth elements to the left of the target. Because shift, at least we should shift by 1, and the maximum we should shift by 3. Because like, yeah, that's how it works. So let's assume I wanna calculate dp of 5 here. It's so slow. So I wanna calculate dp of target 5 on the second row. So it's gonna be dp of 4 on the first row plus dp of 3 on the first row plus dp of target 2 on the first row. So it's basically if I wanna fill this number, I need to sum these numbers. So it's gonna be 2. If I wanna fill this number, dp of 6 on the second row, so I'll need to fill to sum up these numbers. So it's gonna be 1. And the same for this one, I need to add up all these numbers. gonna be 3. And for this one, dp of target 3 second row, I need to add up those numbers. So it's gonna be 2. And then I'll proceed with 0 because like all the remainder part is like 0. And now it becomes obvious how to fill up the third row. So just add the shift, like add 3 last elements shifted by 1. So like here 0, here gonna be this one, here also 0, here 1 as I add up like these 3 numbers, here gonna be 3 as I add up these numbers, here gonna be 6 as I add these numbers 1, 2, and 3. Here gonna be 7, here gonna be 6, here gonna be 3, here gonna be 1, and then 0, 0, 0. And also there is an interesting property to notice. This kind of sequence, first of all, it's symmetrical. You see that it goes 0, 0, 0, then 1, 3, 6, 7, then 6, 3, 1. And the same here, 1, 2, 3, and then decreasing symmetrical 1, 2, 3, 2, 1, and here 1, 1, 1. So the generalized formula here gonna be, let's say, for the for the DP on the target on the draw, let's say draw M, or let's just um, M, and this is a draw. It's equal to the sum of the, let's say, S equal from 1 to K, DP number of combinations um, that have a target that add up to the target T minus S on the M minus 1 draw. So, and we see that it's symmetrical, so we can also calculate some calculate the sum based on the like first I check the 3 elements, like for, let's say for 1 I calculate white here 1, then to calculate 3 I need add up 2 and subtract 0. To calculate 6 I need to add up 3 from the accumulator sum and subtract 0. To add up to calculate for the target 6 I need to add up 2 subtract 1 from the accumulator. So that's gonna be the idea for the solution. So next I'll try to program it really fast. Yeah. So I'll have this int dp array, and I wanna have the dp array basically. Um, I'll call new dp equals new int target plus 1, and then for int let's say, and then have int draw equals 1, and then while draw less than n, draw plus plus, or we can even do this one. And then for first I need to fill up the numbers int equal 1, int I equal 1, I less than k, less or equal k, I plus plus, and then dp of I gonna be equals 1. And then for the every kind of row in the DP array, I'm gonna have this temporary array. So in order to to avoid this matrix calculation, I'll have this like if I need to calculate second row, I'll have the DP array here, and I'll save the interim result in temporary array. Um, so I'll have this here int tmp equals new int target +1, and then I'll calculate the total sum int accumulator. Say I wanna have long, and also for the module I will have int mod equals mass pow 10 to the ninth, and then +7, and then because it's the answer should be by module 10 to the power of 9 +7. Here I'm gonna convert to int. So for, let's say you wanna have this one. So all I'm interested in is in the numbers, which indexes. So int target. For int I, let's say equal so draw, first draw by so from the draw to the I less than or equal draw by k, I need to do I plus plus, and I'll have this accumulator like let's say long, and then I need to have this left one so it's shifted. So for int I equals draw -1, I is greater or equal draw minus k, -1 minus k. So it's gonna be, let's say, 1 plus 1. So it should be draw minus k, I minus minus, and then ln if I greater or equal 0, then arc plus equal dpi, and then for the every temp I equals arc. Then I'm gonna add arc I plus arc plus equal dp of I, and arc minus equal dp of I minus k. Is it correct? So let's say we wanna have here, we wanna calculate 3. So when we shifted from 2 to 3, so it was I was 3. So we need to add this one plus 2 minus I 3 minus this one. So 3 minus 3, so I minus k here. That's right. And then I'll do this dp equals temp, and then in the end I wanna do this and then I wanna in the end I wanna return dp of k or target. So when I'm subtracting this one, I need to go to avoid these negative numbers over mode. Oh no, 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 no. dp okay, I by k by n. Okay. Okay, and I also need to swap the dp array here. Say in temp 2 equals dp, and then temp equals temp. And here dp k by n, k plus 1. And here I also need to do this if the I minus k is greater than 0 or equal 0. All else 0. No, still no. Temp I. So the draw can be maximum. And okay, draw minus 1, I guess this one. So draw. Hmm. So I can be temp, temp k by n plus 1. Still. So the problem is that the target might be like if target less than k, less than n, or target greater than k by n, then return 0. Okay. So how can be their index 13 out of the bounds? Index 13. How there can be index 13? Ah, okay. So I'll still change the accumulator. If I gonna adjust the sequence before I add it here, so what I need to do? So I need to add I minus 1, and then I need to what? Subtract I minus k minus 1. Something like this. So I add dp I minus 1 and I subtract, and then I add model I minus k minus 1. So let's say I wanna find the fourth element, and uh, like I wanna find here ninth element, and I need to subtract like 9 minus 3 minus 1. I need to subtract this one there. Sounds to be true. Still temp I. Why here I have 13 index? Okay, that's better. Hmm. Maybe not like careful enough here. I wonder why this one is not failing. So if if I use a custom use case, Yeah, so I wanted, um, so I wanted to override it, right? So if I wanna do from draw, so the problem is that on every iteration I add like let's say first one was here. So initially, let's say we have 0, 1, 2. Okay, so initially 1, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's say I want to have like k equals 3 and n, let's say equal 4. So initially I'll have the first draw. So 0, 1, 1, 1, and then zeros. So I go um, fill up the second row. Gonna be 0, 0, 1, 2, 3, 2, 1, 0. On the third row, gonna be 0, 0, 0, 1, 3, 6, 7, 6, 3, 1, 0, 0, 0. And on the fourth row, I'm gonna have a 0, 0, 0, 0, 0, 1. Okay, so I don't need that accumulator. Yes, I don't need that accumulator. Accumulator because like I be saving this because I'm reusing temp. I don't need the initial iteration for because I'm reusing temp to uh, dp equals temp and then temp2 equal dp. So I'm swapping dp and temp. Basically, when I do this accumulator, in the beginning, I'm kind of using whatever I saved in the previous steps. So like for the accumulator here, for the, let's say, so accumulator initially should be basically 0. I don't need to save it to accumulate and save whatever the left part on the initial iteration. Yeah, did mistake. So accumulator initially is 0, and when I'm like summing up what's on the left, I'm basically summing up whatever like number. So like in case I need fourth to fill up the fourth row, I will add this one, add this one, add this one, add this 0, because like I'm reusing whatever here. So if I'm reusing arrays, it's gonna be not 0 here, it's gonna be 1, 1, 1, 1, and when I add up and fill up the accumulator, then I'll have the error here. So I don't need this at all. Accumulator initially should be 0. No, not really. And here, um, here I should, what I should do? Well, I should check if the dp of, if this one index I minus 1 is less than previous iteration draw, if I minus 1 is less than draw minus 1, then it should be 0. I minus 1 less than draw minus 1. No, no, not only this one, and also this one. Okay, this is all about it. And then I can also even optimize around this middle point, not to just reflect the array as soon as I reach the middle point. And the middle point is on the, let's say, draw, uh, let's say, S. So I'll have the score on draw, let's have M, on draw M, as score on draw M, have draw M, have draw M, and then score M should be less than or equal m or greater in either or equal than m by k. So the middle point here should be this m minus mk minus m. So here we have 1, here we have 4, here we have 10, here we have 17, here we have 12 plus 7, 18. Um, 6 plus 7, 13 plus 17, okay. Um, so 12 plus 7, 18, 21, 22. Here gonna be 4, 10, 16, 23, 26, 27. Here we'll have 1 plus 3 plus 6, 10. So basically the sum of all of them. Oh no, oh no, oh no, that's not true. Because I need to use just 3 last. 3, 3 last 10, 3 last 16, 3 last 12 plus 7, 18, or 19. Here, odd, 16. Here gonna be 10. Here gonna be um, here gonna be 4. Here gonna be 1. So the middle point here, so here 0, 0, 0, from 4 to 12. The middle point 4 plus 12 minus 4 over 2, 8. So the middle point is 8. Um, that's true. So as soon as I reach mk minus m over 2, and then m plus mk minus m plus over 2m plus m over 2 k minus 1. As soon as I reach this point, I can just start reflecting the array instead of calculating this. Yeah, and even can like, instead of like even calculating and reflecting, probably I can like just save this part, like half of the array, this part, then this part, this part. Yeah, yeah, that's it.